This video is produced for the use of all students enrolled in the EPO 322 Diesel Engineering 2 simulation course held at Cal Maritime. This is the second of two tutorials covering how to complete Lesson 4 using the Kongsberg Diesel Simulator. In Lesson 3, the systems aboard this simulated vessel were left in a condition that would be normal for in-port service. In Lesson 4, we would be within an hour of getting underway, and you have been charged with getting the ship ready for departure. The procedures in Lesson 4 have been made as close as I can come to what an actual situation would be on a ship. Now, on the actual ship, you would have a checkoff list in today's world, and you would check each one of these procedures off. But what we are going through is the general procedures for any vessel, and you would have to, aboard the vessel you're on, find those individual valves and system changes that differentiate a little bit from the simulator. But again, pay attention with this particular lesson, because this will be very close to what you're doing in actual life. Now, one of the primary things, and we want to happen right away, is we want to have the main engine turning over on the jacking gear. There's a few reasons for that. One, by turning the engine over, then we know that all the parts are lubricated. There could be water in the cylinders. You have a cylinder that can be as much as, on a modern 980 millimeter bore engine, slow-speed engine, we're talking a cylinder that's a meter around, and your indicator cock is quite small. You would not want to discover that there's water in the engine when you're rolling it over on air. Well, by turning it over on the jacking gear, you are going to observe the indicator cocks and make sure that water does not come out of any of these, because that's a showstopper. You immediately have to notify the first in chief, shut the turning gear down, and investigate why there's water in a cylinder. But at worst case scenario, the thing that would happen is, as that cylinder comes up and there's water in the cylinder, it would stop the steering gear. It really wouldn't do any damage. Well, prior to getting this plan underway, you would typically, you have to have the lube oil up and running, and that would include not only for the main engine but also for the stern tube. Now, part of this, and I want to remind people really it's a good idea to do this first thing, is Burmeister Wain in their instructions specifically talks about always making sure that there's air on the exhaust valve cages prior to putting your lube oil system on. So we're going to go to, and I would do this first thing so you don't forget it, is go to whatever start air bottle's on the line and line up the control air for the main engine. Now, many ships leave this on all the time, but there are some that do shut it down. Let's get the simulator running. Specifically, on this main engine, each of the exhaust valve cages uses a pneumatic piston instead of a mechanical spring to close the valves, and that is called spring air. Now, you have block valves, and this is an interactive description of the Burmeister Wain pneumatic control system for an MC engine, which is what the simulator is based on. All of these valves, by the way, are actually identically numbered and are very accurate to what is on an actual vessel. Now, you have block valves. One is for the air distributor, the safety block, and the main start block. One of the that they did leave out, though, is for the spring air. And some ships actually will even turn this spring air, open this block valve here. We don't have that option, or I would have had you open that also. I just want to make sure that everyone knows that you have to put spring air on and make sure it's on to close the exhaust valves prior to start up the main lube oil system. The reason for that is the main engine lube oil system is the source of hydraulic fluid for your hydraulic push rods on the exhaust valve. You use a hydraulic system to open the exhaust valves in operation. And the main oil system, once it's pressurized, will feed in a small amount of oil into that system to displace any air in the system, purge it, and keep it full of oil. Then when the exhaust valve actuator starts moving up, what happens is the oil in the hydraulic push rod is locked and none of it will flow out, and so all of it goes to pushing on a piston that opens the exhaust valves. If you were to put the main lube oil system on without having spring air on, the exhaust valves are already fully extended, and by adding more pressure onto that fully extended valve mechanism, you can over travel it and cause damage. So that's, I thought, was an important concept that was built into this simulation. So put your spring air on prior to startup of the lube oil system. All right, let's go to stern tube. This system is for a tanker. This is pretty close to what you have on the Bear. Here is your stern tube, and you have lip seals on the stern tube to prevent water from leaking in or oil leaking out, either out into the sea or into the engine room. Realize the majority of the oil pollution incidents were from the stern tube. It's not a lot of oil, but any oil discharged into the environment is an oil pollution incident. So to prevent that, one of the things that's happening, in many cases you'll see this is your stern tube, and that is oil lubricated with the gravity tank feeds down, and there's your flow rate down into this and lubricates that bearing. And remember, it's got to take the full weight of the shaft plus the overhang propeller. Now, so if the oil differential pressure is too high, that could force it past the lip seals into the environment, and you have an oil pollution incident. On the other hand, if the sea pressure outside the propeller gets too high, then the water can push through these lip seals and get into the bearing. That's a very serious thing to happen, because the oil and water will not lubricate properly, and you'll get excessive wear and corrosion of the stern tube bearing. And stern tube bearings, that is not a cheap item to replace. Think about how much time and money has to go into removal of the propeller, removal of the main shaft, and then pressing this huge bushing out of the hull. So you don't want to get excessive wear, and to ensure that you don't, you need to have a clean oil supply without any water in it. And you do at least minimal monthly purify the oil in the stern tube, and that's extremely important. In other words, you're going to take a suction out of the lube oil sump to a purifier and clean it. And check for water when you do that, of course. And also, by the way, I have seen severe contamination with salt water, and it was actually the oil coming out was green and lumpy. It was that bad. So do a visual on the oil coming out, and also you're checking for water. When you notice the graphics here, that is feeding on this one. That is feeding on this aftermost space between these. You have two lip seals, 1 and 2, to prevent salt water coming in, and 2 lip seals from preventing oil the opposite direction. And notice they're facing different directions. This little gravity tank, right, is filling that space in between. In some cases now, they are putting biodegradable oil into these little seal tanks, gravity tanks, so that if there is a leakage of the oil into the salt water, then being biodegradable, it will degrade and is not an oil pollution incident. And in many cases, that's what they're doing. In some cases, I'm also seeing where all of the oil in the stern tube used for lubrication is biodegradable. And there have been discussions on many ships of going back to water lubricated bearings, because this is a problem. Now, the other one, this is a tanker. Tankers, which are bulk, we're going to say on this one too, because it is designed that way, is a bulk crude carrier, can change draft dramatically. When this is compared to being fully loaded to being empty. In fact, we're coming out of the shipyard, and so you don't even have ballast in the tanks. You're going to see the top flukes of the propeller sticking out of the water when it's this unloaded. Now, when it's loaded, depending on the vessel, but an ultra-large crude carrier can be as much as 20-meter draft change. That's 60 feet. So if that propeller is 60 feet lower when it's fully loaded, that means that the hydraulic water pressure outside the stern tube is going to dramatically change. So what they do is they provide 2 gravity tanks. We're on the lower gravity tank because the vessel is unloaded. And even so, they're giving you a lube oil to saltwater differential pressure. We're a little bit on the high side. But because we're so unloaded, we can't change that. That is set by the height of this tank. Now, once this vessel is fully loaded, and what you're doing is, let's say we're going up to Alyeska, we're loading crude. About halfway in that process, you're going to switch over to the high gravity tank. So you change on a tanker, you change gravity tanks depending on the loading situation of the vessel itself. Now, we're going to put these in automatic. Before you try to put them in automatic, this pressure, right? In this case, we're saying this is 13.5 millimeters of water pressure. What we're talking about with this pressure, that is set by the height of this tank. And you notice that the tank is overflowing. So this pump is a single speed pump. It is delivering more fluid going in than what is needed. In fact, if you look at the flow rates, look at the overflow rate is 11, almost 12 tons per hour, and only 1.6 tons per hour going into the stern tube. So quite a bit of the fluid is actually, in what they're showing here, is overflowing. So the height of this tank is what's setting up your pressure of the lube oil going to the stern tube. Now, if you put them in automatic too quickly, and because you're having to fill this tank up, then what will happen is, because of the low pressure on the output, it will automatically start another pump. So you want to wait until this is overflowing and then put both pumps in automatic. Putting only one pump in automatic doesn't do anything. They both have to be set up so that it can shift from one to the other depending on pressure. Let's go over to the main engine lube oil. On the main engine lube oil system, you have a cylinder lube oil storage tank, and that is feeding into a cylinder day tank. Cylinder lubricating oil is vital on a big crosshead engine. You have no splash lubrication of the liners with oil because it is a crosshead engine and it has a piston rod seal. So there is no total disconnect between the combustion spaces and under the liner and the crankcase itself. So you have to supply lube oil to lubricate the liners. And that is a measured amount of oil, and it is delivered through injection points around the cylinder. This is one of the biggest advantages of a slow speed, because the fact that when burning high sulfur fuels, you can use a high TBN oil, usually about 70, the TBN of about 70, to neutralize any sulfuric acid that is created during the combustion process because of the sulfur in the fuel. And about today's world, it's about 4% sulfur. Sulfuric acid etches metal from the liner and causes wear. So because we can neutralize this sulfuric acid, big slow-speed crosshead engines, there's other reasons, but one of the reasons that it is considered one of the major reasons why they have the lowest liner wear rates in the industry. And liner wear and piston ring wear, those are the big maintenance cost when running one of these diesel engines. So even though we are not doing anything with the cylinder lubricators, there's no provision on the simulator for us to operate those. Realize whether it's a mechanical system or an electronic system, prior to rolling over the engine on the jacking gear, you always have to supply cylinder lube oil for a short period of time to lubricate the cylinder before you turn it. All right, the other one we'll talk about a little bit is this camshaft lube oil system. It has a separate tank, and the tank is 1.5 cubic meters when full, which is 1.5 metric tons of lube oil. The main sump, in comparison, is 58 metric tons. Now, with a crosshead engine, the oil in the sump should never have to be changed for the life of that engine. But on the Burmeister Wain, on some of their engines, the fuel pumps, the fuel that is used to lubricate the pump plunger and barrel can drip onto the camshaft follower and then gets incorporated into the lube oil that is lubricating both the camshaft lobe and that follower. So in other words, you get fuel dilution. And this increases steadily over time because those fuel pumps, as this engine is running, is always dripping this fuel into the lube oil. So what has happened is Burmeister Wain has a separate system for camshaft lube oil. And when this camshaft lube oil tank becomes excessively diluted with fuel, you would dispose of the oil in port. When you're in port, you're going to drain the oil out, and then you would refill it. Okay, so when starting up this system, I'm going to go ahead and start the pump up. Make sure you have lube oil flow to your bearings. We are low in temperature. That's why it is important that, let's go ahead and clear the alarm. It is important that you are controlling it manually, in automatic. And I want you to notice that this three-way valve is shifting right now, and the flow is all going towards bypass. The only thing heating this sump has been our lube oil purifier, and we don't want to lose that heat. All right, so it's being shifted over so that we're not cooling it. Now, if I had drained this camshaft lube oil tank and needed to refill it, basically this valve would be opened to add oil to that, and once you get it to a normal level, you would then shut this off, and now we can actually put all of our pumps on. Whenever you put pumps on prior to putting them in remote, make sure that you have system pressure and flows established. Otherwise, before you try to put them in automatic, otherwise the other pump will start. All right. So again, if this becomes contaminated with fuel and your report comes back from the oil testing facility that you have excessive dilution, you would drain the tank empty in port, refill it off the main sump, and then put more oil back into the sump to establish its level again. You do have to, on this type of system, you do have to replace the oil in the camshaft lube oil system on a regular basis. Nothing to do with the camshaft as far as the bearings being different. Everything doing because the fuels pumps, the high pressure fuel injection pumps on these designs leak a little bit of fuel into the oil. All right, once this is done, we're going to immediately go the turning gear in and start the engine revolving. All right, to do that, we'll come down, engage the turning gear. We're going to go ahead and we'll open these up. And again, think of the opening here in the indicator cock compared to the cylinder. You wouldn't want to run this over on air with water in the cylinder because this is so small, it's a limited amount of protection that it could afford you. All right, now with those open, we can go down and we can go ahead and put this on. And then when I look over here, I can see that my shaft is turning, but it's turning at a very slow rate. All right. If for some reason you're having trouble with the virtual, you can go to local control and you can engage it here. Let's go to panel directory and pump compressor control. Now, when I put this in automatic, what is going on is this is standby status. If the pressure in the system falls, it will automatically start another pump up. Now, typically, it will actually run both pumps. It will not shut the other pump down. And you will get a disruption of the system and an alarm to tell you that the standby status is activated and you need to go down, investigate, shut down the pump that had been running, and investigate why pressure was lost. But typically these systems, if the pressure is lost, it will start another pump, but it does not typically shut the first pump down. As part of your troubleshooting, you never want to run two pumps at the same time. You would secure it. Now, what has happened here is exactly that. For whatever reason, it has started the camshaft lube oil pumps, and I have two pumps running. So I'm going to take it out of auto, and I'm going to shut number 2 off. Now, just so you know, and this is the reason I let this come up, is that for right now, for whatever reason in this version, it's tending to start this second pump when you first switch over. Just wait until the end of the exercise before you end the exercise and put it in automatic and watch, but I don't think the pump will start up if you just let it sit for a little while. So, but watch for that. You don't want to, as you walk away, see two pumps running. Now, the other what we're doing is a COI, Certificate of Inspection. Every year you test the automation systems. And one of the tests that is typically done is testing to see if the standby status works. And you're going to be doing that on just 3 of the pumps. With the Coast Guard, I would be testing over all of these. But to keep this scenario in a reasonable time and to get the point across, you're only doing the saltwater, low temp, and high temperature pumps. All right, the next thing I'm going to go to is talking about the turbo generator. And right now, I've already got the turbo generator rolling over just on the turning gear with the vacuum up, being drained and ready for service with already the vacuum has been raised. So we're at the point now where we're turning it over we made sure that we have an oil supply to lubricate the bearings, and we're having the turning gear on while we have gland sealing steam on. I had to put gland sealing steam on to raise vacuum. The gland sealing steam tends to warm the shaft of that turbine on either side, preventing the leakage of air into the condenser. But also, whenever you're warming up, getting a turbine ready for operation like this, you always have the turning gear revolving the turbine prior to actually startup. Otherwise, you take a chance that the turbine rotor can sag and cause vibrations on startup. So, to start this up, we're going to first take the turning gear out. Now, I've got the superheated steam just cracked open because we're just draining the system and doing a warm-up. And we have it selected to the oil-fired boiler because we have no heat being generated by the exhaust gas boiler. This is my gland sealing steam to my gland seal regulator that supplies about 2 psi steam to my gland sealing glands, which prevent air leakage. This is my superheated steam drain. This is the return to the condenser to retain that water from the gland sealing steam. And then this is actually I would say an atmospheric drain tank. And then this is the exhaust from the turbine to the condenser. This is what they're calling an emergency stop valve. If this unit trips, it will trip. This valve will slam shut. And that can be on any of these: high hot well level, high condenser pressure, high boiler level. All of these are trips. Right now we have the turning gear, so this will not open because of showing this. So to be able to apply steam, I have to reset the trip from now that I've pulled the turning gear out. The other thing on this is my governor, and the governor set point is 6,400. You notice the governor right now is wide open. So we are controlling the startup and the speed that this turbine's coming up with the throttle. Now, one of the things, I'm going to go ahead and put 15 in and get it revolving. And you should see the turbine speed come up. One other thing about the Kongsberg on this startup procedure, you can tell that they're motormen and not steam. This is a 900 kW generator and running through a reduction gear. So your steam turbine runs through this reduction gear to run this 900 kW generator. Generators in startup have no real load. There's the only thing we're talking about here is the friction losses in the bearing and maybe some windage. It only takes about a horsepower to revolve this over. So the problem on opening up the throttle to bring it up is generally trying to just crack it barely open, or you'll overspeed this unit. Here I'm opening it at 15%. That's not realistic. Maybe there's some slop in the valve. But the other one is once it's started, it doesn't come up quickly. Normally what you do is you just crack the throttle until you see the steam turbine, the output shaft to the generator. As soon as you start barely seeing that move, you just step back, and over about 5 minutes, it'll slowly come up to speed. Again, it only takes 1 horsepower to bring this up, and I've got over a 900 horsepower available. So the one thing that I'm a little unhappy with the simulator in this instance, that you're going to have to slowly open up the steam to it. This acts like a pump, not a generator. But realizing that what you can do is crack it like this, get it turning over, and then go do other things and come back after 3 or 4 minutes and then go ahead and bring it up. If you try to bring it up too fast without warming up, you'll get excessive vibration. But again, this should start here, and what happens in real life, it will keep increasing slowly in speed until it gets up to 6,300 RPM. And how you know that the governor has taken control is you can usually look at your lifting bar on the steam turbine. As soon as you crack it and get it moving, that turbine's going to slowly come up to speed, and then you're watching the governor, and as soon as it closes the lifting bar, then it has shut steam off to that turbine. You know you're up to speed, and then you could go ahead and open up the superheated steam from the oil-fired boiler 100% and open up this 100%. So I'm going to bring it up a little bit faster than I normally would. I'm going to go ahead and say that we've been going for 5 minutes. Open this up. And then I'm going to bring it up pretty quickly. Now you got to watch your vibration. You shouldn't be anywhere near as fast as what I'm doing it. And by the way, I do check. I look back on some of the students. I can review their exercises, and I wouldn't want you to see bringing it up this fast. But while we're doing that, we're going to hold her there and see where she goes. And my vibration is still low, and I'm kind of comfortable with that. So let's talk about a little bit why we're putting this generator on. Now you notice with the loads that we have, we're right now running 2 generators. This Power Chief load diagram is giving you a visual representation how the power management system works. These are number 1 and number 2 generators, the loads that are on them. So basically these are looking at load on the generators, and this green and red. If both of these drop down into the green, then it is going to stop a generator depending on the priorities. If I had 1 generator on the line and that comes up into the red, it would automatically start another generator. So this is giving you where that permissives are. So let's go back and bring this guy up and running. And I'm watching RPM here. And again, you just crack this valve open and it'll come up to speed pretty darn quickly. This is really absolutely ridiculous to me. It bothers me. All right, so I've got my oil-fired boiler. I've got that 100%. I've got this at 100%. I'm up to speed. I'm ready to put this unit on the line. At this point, I'm going to close my drain. I am going to, and that's about good. I got my oil temperature up. I want to wait for that before I put the cooling water on. And then I am going to start a main condensate pump. By the way, this main condensate pump, I have vacuum pumps, not an air injector. I don't need any water supply condensate to cool the air ejector. There's no reason to run this until you have steam coming in to be condensed and condensate in your hot well. And you can see it's still low. Now, the other thing, don't forget it when you put it on the line though, because otherwise it'll overfill. Now, I want to bring up too that it's showing a little bit high on my steam temperature. Now, what's going on is there's not a heck of a lot of flow right now through that superheater. But I want to point out that we are at a very low firing rate, 2%. Right? I mean, this thing is barely idling. This is about as low as you can go on this boiler. It's barely bubbling. So I'm not worried about that superheat temperature. I think that is normal and is not a problem. Now, I'm going to get the turbo generator ready to go. I want to be slightly high on the voltage at 60 hertz. I need another screen when I'm doing this, so I'll bring that up. All right, so I'm going to need to be using the synchroscope. And I'm going to pull that up here. And I'm going to my other screen put the generator. And I'm going to sync this up. Okay. And then I'm going to apply some load. Now let's get off here and we'll go back. Now you notice I'm still running 2 generators. But when you watch this, see how she's getting down in the green? Up. So it's going to start disconnecting. So I'm loading this up on the steam turbine. It will automatically take a generator off the line. It's going to take, see it's decreasing here. So it just disconnected, and that was due to the power management system. And then I'm going to go ahead and put this in automatic, and I'm going to run the steam turbine and a diesel generator. The reason I'm doing this is on the bow thruster, when you're running the bow thruster, if the pilot and the captain, or it's really the pilot, if you're overusing that bow thruster, if you use very large commands, you can overload the electrical system and you can have preferential trips or a blackout of the plant. So when the bow thruster comes on, in real life, I'd want 3 generators on the line. Once the command is given to start up the bow thruster, I would take number 1 out of automatic, place it on the line so I have 3 generators, and put it in alert mode, and then that would maintain all 3 generators on the line, and I have plenty of power, and the bow thruster could not cause a blackout situation. All right, I think that's the major points that I wanted to go over here, and I thank you very much for your attention.